Welcome to the Level 2 video on repeated integration. Today we're going to be talking about fixed limits and clarifying exactly what they are. Okay, so what are fixed limits? Well, if the limits are fixed, then the domain of integration, okay, so this is our region we keep calling R, is rectangular or square, etc. So not triangular. When the limits are just four numbers, a, b, c, and d, and our region is rectangular and square, then we say the limits are fixed. And this means something actually quite special. It means we can change the order. And by that, I mean that the double integral from a to b and to c and d of the function f in x and y with respect to y and respect to x can be completely swapped around. The order can be changed, and it can be the double integral from c to d and a and b of the same function in x and y, but this time with respect to x and then respect to y. So let's jump in and have a look at an example, and we can solve it in both orders to highlight exactly what we mean. So find the double integral from 2 to 1, from 2 to 0 of x squared plus 2y with respect to y and respect to x. Our solution is if we take the integral, the double integral from 2 to 1, 2 to 0 of x squared plus 2y with respect to y and respect to x, and we keep the order the same for now, and we just compute the integral of y first. So we keep the integral of x, we integrate with respect to y to get x squared y plus y squared, and we substitute 2 and 0, and we have the integral from 2 to 1 of 2x squared plus 4, and then we go ahead and compute our integral with respect to x, so that we have 2/3 of x cubed plus 4x now from 2 to 1, substitute 2 and 1, and we have 16 over 3 plus 8 minus 4 over 3 plus 4, simplifying this, gives us 26 over 3. Okay, so alternatively, we can change the order. So the double integral from 2 to 1 and 2 to 0 of x squared plus 2y with respect to y and respect to x. This was the original integral, but let's swap the order now. So we swap the limits so we've got from 2 to 0 and from 2 to 1 and from 2 to 1. Our function remains the same, but we swap these as well. So now we have dx dy rather than dy dx, and we compute the integral with respect to x first, so we keep the other integral out the front, and we're going to have x cubed over 3 plus 2yx from 2 to 1. We substitute these values so that we have 7 over 3 plus 2y. Then we compute this integral with respect to y. So we have 7 over 3 y plus y squared from 2 to 0, and substitute these values to get 14 over 3 plus 4, but then we've got 0, so we've got nothing to take away. Collecting these two together, we have 26 over 3, which is consistent when computing the integral in the opposite order. Thanks very much for listening.